Should know?
Yeah,
Okay. Alright, I'm just going to go back to this so I can show the camera, and then voila. Okay, so mechanical energy basically takes our two most common, most abundant, most well-used, well-talked about forms, and I say these are the two most important forms of energy that we are going to talk about. Okay, potential was in some of the other forms of energy that we've listed on the board, and kinetic was also in some of the other forms of energy that was listed on the board. It's pretty abundant. Okay, so if you want to know the mechanical energy of something, you would have to find both the potential and the kinetic and do what with them? Add them. Yeah. Alright. This is the one we're going to camp on the most. Potential energy or gravitational potential energy. No. Good catch.
Oh, I really know.
Everyone has those days. Grab it.
Like the water.
Everyone has those days. Everyone.
Like today. That was
Got my foot caught in my lanyard.
Wow.
She tripped on the backpack like
Yeah, fire hazard. Okay, I'm going to get this in. Sorry, I made a typo. I made a mistake.
It's okay.
I am a sinner saved by
Like Frog
grace.
Jones.
Come on, Bobby.
Oh, my favorite now.
I'll make sure that I don't lean back too hard on this corner again.
Oh yeah, that was
That's why I have a hole in my other
Oh,
pants.
yeah.
on
You're like a dentist now.
Yeah. Oh,
Yeah, I just leaned back on this corner and rip. What?
Looks like there is some. I ripped right where the.
Well, stop staring. Okay. Here we go. Back to your book, probably time. Name of the variable.
Potential.
Gravitational potential energy. That page where we have all our labels, all our variables that we said was very, very important so that we know what we're doing. Okay, gravitational potential energy is the name. The symbol is P E sub G.
Heck.
Oh crap.
And the most common unit is? Any ideas?
Joules.
Thank you.
I said Jules. Is this vector a scalar?
I'm pretty sure it said that at the very beginning of the notes what
Scalar?
energy was, so.
Scalar.
Okay? Now, we spent quite a bit of time the last chapter talking about free fall and things like that, and gravity's acceleration on objects. Well, how much does gravity accelerate any object, regardless of the mass? 9.81 meters per second. So it accelerates a feather at 9.81 meters per second squared, and it accelerates Bobby at 9.81 meters per second squared. You fill in the blank, it accelerates it at. Okay. Now, this is assuming at sea level. Why do I say that? Do you remember what the importance of that is? Yeah, altitude is going to change the gravitational attraction. What's the gravitational attraction for the most part in outer space?
0.
Pretty close to 0. Because we said gravitational force is dependent upon the mass and the distance between the objects. And when you're in outer space, are you very close to the center of the Earth? No. Okay? Now, we've got M. What is M?
Mass.
This is a constant, just how much gravity accelerates an object. What does H stand for?
Height above
Height, okay? And you remember, if I have this on the ground, does it got any potential energy to gravity?
Yeah.
No.
No. Okay, well, let me explain what I mean by height above 0 level. We can essentially set any level to be 0. Usually the common place where we set 0 level is usually the ground. Because is that going to have any potential energy to be pulled down through the Earth, really? No. So, I mean, technically there's probably potential energy, but it's not a lot. Okay? But then I gave an example of lifting it up, and then we said that up here it has a decent amount of potential energy to gravity. And how did we know that? How do we know that it has potential energy to gravity? Okay, but like if it didn't have any potential energy, well, if I let it go, it would just hover, right?
No.
Yeah.
If it didn't have any potential energy?
Yeah.
Yes. Right? It doesn't have any potential energy, because remember, energy gets converted. One thing energy can be done is it can be converted one form of energy to another. Remember that? One of the 3 things it can do. What are the other 2? Can do work and be converted to matter. Alright, so when I lift it up, it has potential energy that when I let go, that potential energy gets converted into kinetic energy and then acoustic energy when it hits the ground. Okay, not the only, but the main portion of it. So, here's the next question I want you to answer on your sticky note. So I haven't told you the answer to this. I'm curious if you can figure it out. We have 3 variables here. Mass, gravity's acceleration, and the height. Here's the question I want you to answer. You will have a minute after I give you this. It says, what is the most important variable when determining the potential energy of gravity, and why? Which of these is the most important variable for determining the potential energy due to gravity, and why? Go. No. I don't expect you to all come up with the correct answer. I'm just curious if any of you can. Think about it. I'll give you 2 minutes for this, so you can think about it a little bit more than. Did it again. Which variable is the most important for determining potential energy due to gravity? Is it mass? Is it G? Is it height? Which variable is the most important variable when determining gravitational potential energy? And then why do you think so? Why do you think what you put down? Doesn't have to be right. It would be awesome if it's right. I haven't told you the answer yet. When you're done, put it on the board. No, don't put it in. I'll tell you next. Don't put it there. Okay. I haven't taught you what it
It's a
is.
baseball. We fall down, we go not finish the first 8 years, we just learn how to take off our gloves.
You're what?
Learning about first aid and health,
Oh, yeah.
all we know how to do is take off rubber gloves.
Oh, yeah. Have you guys watched Claire's video yet?
I am putting on my gloves. Is the scene safe?
Oh, you just started today?
Yeah.
Yeah.
We just finished
20 seconds.
the emotional and mental stuff. I was thinking we're gonna go to some
We did social last year. Yeah, we did social last.
5 seconds.
Stevie, 2, 1. Oh! Failed. Time's up.
Okay, so let's see what we put.
Who's the son?
No. All right, we've got height above 0 level because it could change the other variables. We got 1 for height. We got height because we are finding the height. We've got height because all mass falls at the same speed. I think it's mass because the more mass something has, the faster it will move. Is that true? No. Height, because the higher it is, the more potential energy it has. We got G because it is slowing for gravity. We got G, without it, the object would just hover. Height, because the further away your object from the ground, sea level, it has a potential energy.
Yeah.
Don't be able to read.
H, because mass doesn't affect the gravity, never changes something. What did I say? H, height. Gravity, because it's gravitational. Height, because the higher in the atmosphere, the less gravity, and the lower there is the gravity, something like that. Height, okay. Height, because how high the object determines how long it will fall and how much potential energy it has. Height, since gravity is always pulling down, and it changes the entire equation drastically. Gazelle. This is yours.
What? Gazelle.
Gazelleration. Due to gravity, you need to know the.
Just put G,
G acceleration.
but I did not put gazelle.
Looks like gazelle. H, because it may have more of a chance to change the gravitational potential energy. Gravity, because if if you are somewhere not at sea level, then gravity is different. Okay. There's one more.
There's one more. Wait, that was gravity.
They're equally important because without gravity it wouldn't fall. Okay, I guess I can kind of understand that. So we'll say other.
Mine was gravity.
You need to put one in G.
Okay, whatever.
This one. It doesn't.
Not really that important. The answer is height.
Yay!
Here's why. Now most of your Y's were wrong.
Yeah.
Okay. First off, did we say that mass affects gravity's how much gravity accelerates an object? Okay. Now, assuming we're at sea level, does G ever change? No. So G is going to be the same no matter what, right? So is that? I mean, that's a constant. So that's not going to have a significant impact on what the potential energy. Do you need it? Yes. But is G going to change? No, unless we get like way up in outer space, but we're not going to be doing that. Okay? Yes, masses can be different for different objects, but could I change the mass of this? No, I can't change the mass of this. I can't change the fact that gravity accelerates an object at 9.81 meters per second. But what is the one thing I can change? It's height. Yes? Okay. Yes, you're right. Technically, but yeah. You understand the point though, right?
Yeah.
Okay? I cannot change the mass of this. I cannot change the fact that gravity accelerates all objects at 9.81 meters per second squared, but I can change the height. And we should know that when I drop it from up here versus drop it from here, which one has a faster speed when it hits the ground? Which one has a faster speed when it hits the ground? There or there? Higher one. Which means that it has more kinetic energy when you drop it from up here than when you drop it from here. But where do you think the kinetic energy came from? It's potential energy, which means the higher you are, the more potential energy it has. Does that make sense? Height is the #1 factor because it's the variable we can change. Can't change the mass of this. Can't change the g of this. But I can change what? Height. Let's do a problem. I'm going to do this one, and then I'm going to give you a couple to do. Ready? Write it in.
Say that I just used a book
Let's do some math. In the book they have GPE, is that okay?
GPE. Yeah. Good old Bobby. Always screwing things up. No other textbook have I ever seen it that way. But Bob Jones, you know, they just want to be different. Is m a new variable?
No.
So you know the most common unit for that, right? What is it? Kilogram. Is h is kind of a new variable, but it's just another way of describing a variable we've already talked about. Distance. Okay? So height and distance is the same most common unit. Okay, if I wanted to measure how high something is, wouldn't I measure it with distance? Everybody? Yeah?
Yeah.
Okay? And g is not a new variable, is it?
Yeah.
Nope. So the only thing that we're adding here is talking about the potential energy due to gravity. So just like always, now I know you're probably, it's a good guess to assume we're using the potential energy due to gravity equation. However, we still need to label what we've got. The best way to determine what type of equation to use is by looking at the variables. And how do you get the variables? Units. Okay. We see our first number and unit. Kilogram. Most common unit for? Mass. Okay. I want on all tests for you to label down the side. I might actually start docking you if you don't do that. Because usually if you can't do this, you'll never be able to do the math. Okay? And then they give us a joule. Now they do follow it by saying this, so thank you, equation, or I think I made this one up. Okay? What's that? Let's keep reading. How high? What does high probably tell you?
Height.
Height. And then we're missing a variable.
G.
Oh wait, you know G?
Yes, 9.81.
Oh, duh. That one actually hurt a little bit. All right. So here's our equations. We are going to take what they equal and replace them in the equation. So 45 is equivalent to phi. Our mass, our m, is equivalent to 4.5. 9.81 is our g. Times h. What shall we do?
Parentheses, multiply 4.5.
Yeah, you could do a variety of things. You could multiply this first and then divide, or you could divide them both. Whatever you find is the best way to do it for you. What is this times this? Anybody? 44 point what? 145?
Yes.
We're dividing by 4.5 and 9.81.
1.02.
How high is it?
1.02 meters.
Anybody have a second? Is that, or
Yes, that's right.
1.02 you said?
Yeah, meters.
Now why is it a meter?
And that's the distance.
Okay, now listen. You're probably thinking, this is really goofy units to cancel out. Well, remember, joule is a derived unit, which is a Newton, not an H, is a Newton times a meter. Then you're dividing that by a kilogram times a meter per second squared, which is the derived unit of a Newton. Good job. So that's where the newtons cancel out. They cancel out with this, which is what a Newton is, leaving you with a meter. But there's a simpler way of thinking about it. What is the simpler way of thinking about it?
It just works.
Okay. If everything else is in your most common units, your answer will be in its most common units. Cool?
Yep, cool.
Everybody get this answer. I'll get it into your calculator.
Yep.
All right. I want you to do this one. You ever heard the infamous Sir Isaac Newton figuring out gravity based on an apple falling on his head?
Yeah.
Okay, there you go. Good.
Joule.
We're gonna figure out exactly how much potential energy that apple had. We're gonna determine whether it hit his head with a lot of energy or not. The answer's no. But
Because it didn't happen.
yeah, it did happen. Raise your hand when you have an answer to this. Also raise your hand if you have a question. Either or is fine. Got it. What should you be doing first? Writing your variables. What's your unit? Ouch. Yep. Yep. You missed the 0.45. Yep. Otherwise you got it, yep. Good job, Johnny. Good calculators.
Right now.
Not now. Get a calculator. Yep. 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 Yes, sir. What's the unit? Did I check you? Yep. Phone not checked. Yep. Still working? Oh yeah, where is it? Yep.
Snap at the
Okay. Yep. Okay, don't do that. Don't square it. You're looking at the unit and thinking you have to square it. The only time you square it, Katie,
Now it was silent. Just okay.
don't leave, I gotta give you a worksheet.
Yeah.
It's if in the equation it had like a square there. The unit, ignore. You don't square when you're doing the units. So you're not going to square that, you're just going to multiply it. Yeah, we learned. Stop, Mari. Come on out. Did you get it? What? Here's some. Audrey, did you get that answer? Anybody not got one yet?
Dang it!
You get one? Mari, did you get one? Johnny?
I did not.
Everett, did you get one? Get on the board.
You guys are hard to talk about.
Nothing. Fire.
Okay. Read.
It's
Here's all the board. Do it. And then do it. Wait, what? No, what would be the distance?
Because it's like, if we lose or win, we're going to play again, so I'll probably go see that next year. Oh, Michael. What? That's what they all say, Michael.
Replace the number with the letter. Or the letter with the number.
As long as it doesn't actually. I still find that funny.
Use mine right there on the